All right, we're gonna try relative motion part 3. What we've got so far is when things are going in the same direction, the velocities, their speeds, we'll come to the word velocity in a bit, their speeds kind of added up. So Isaac's sitting on the paper, car driving across the paper at a rate of 2. Isaac sees the car moving at 2 relative to him. But if the paper's moving across the whiteboard at 1, then Albert's chilling out way over here. He's going to see the car moving at a rate of 3, the 2 and the 1 combined. I hope that's a little bit intuitive. If you've ever goofed around and ran up a down escalator, or if you've been at a big airport where they have those conveyor belt people movers, if you're on the conveyor belt, say the conveyor belt's going one way, someone standing on the conveyor belt's going to move, but if you're walking on the conveyor belt, you're going to catch up and pass them. You have the effect of relative to the ground, you're going faster, so you get to where you're going a bit quicker. Hopefully intuitive. We'll come back and I'll type up some notes to get the vocabulary a bit better, but that's really what relative motion is. Now we can play the what if game. What if the paper speeds up a little bit? What if we speed up the paper so that's also going at 2? If this is making sense, this shouldn't be a big leap. To start off, I'm going to push the paper to the right. Everybody's going to stay in their same position. The car is going to move across the paper at 2. Well, you do the math in your head, have an idea what it's going to look like, and take 2. Should look something like that. The same basic idea, the 2 and the 2 add up. Albert would say that the car is going at 4, the 2 plus the 2. Isaac would say the car is going 2 between those guys, and still now a new number, 2 between those guys. What if I flip it? So I'm going to put the car on the blue paper and have the car go to the left, but I'm going to have the paper going to the right. I'm not going to be able to do it perfectly, but I'm going to try and match their speeds. What if the car is going to the left at 2 as the paper goes to the right at 1? What would everybody see? I'll set it up while you think about it. I'm going to give it another, no, I think we can do it like this. I'll get the car going, and once its wheels are on the paper, I'll start to move the paper. Okay, if I do it right, here we go. Take 2, here we go. I kind of got it there at the end. If I do it right, the paper moving to the right at 2, the car moving to the left at 2, the 2 and the 2 add again, but this time because they're in opposite directions, it's like an integer thing. We're going to come back and use some big fancy words like vectors and velocities, but when we add these two quantities, direction is so important that this time the 2 and the 2 don't add up to 4, the 2 and the 2 add up to 0. Isaac still sees the car going at 2. He would argue that the car is going 2 to the left. The car could argue Isaac's going 2 to the right. Albert still sees Isaac moving at 2. Albert would say Isaac's going to the right at 2. Isaac would say you're going to the left at 2. The weird one, the moneymaker, is what Albert and the car see. The 2 to the left of the car and the 2 to the right of the paper combine to make 0. So if I did it right, it would kind of look like this. As the car's drifting, it would kind of look like this. As the car's going to the left and the paper's going to the right, they completely cancel each other out, and we don't see the cars from the frame of reference of Albert, or from you guys with this camera standing still. The 2 and the 2 combine to make a 0. Again, that's kind of intuitive. Let's say you did goof around and try and run up a down escalator. You have to run really fast because your speeds are going to kind of cancel each other out. Or if you're on that people mover at the airport and you wanted to talk to somebody that wasn't on the people mover, you'd have to turn around and walk backwards, matching the speed of the people mover so that you would stay still relative to that person, on the ground. Or the classic treadmill. Instead of a piece of paper, it's that big, whatever, rubber belt that's going across the ground. You have to match the speed of the treadmill. If you run too fast, you're going to creep forward on your treadmill. If you run too slow, you're going to fall off the back of your treadmill. So hopefully it's a little bit intuitive. We'll pause the video here. We got one more thing to think about, and then we'll chug through and set up some definitions and things on paper.